Welcome, welcome, welcome one and all to Nick Does Maths. Today we are solving a cheeky differential equation. I'm in a very differential equation-y sort of a mood at the moment. And it looks like partial fractions as well. So let's find out. Here's what we got. Here's an initial condition. It looks disgusting, but I figure it's just there to make everything work out nicely for us. So what do we have? Yep, first order. Yeah, fairly linear. We just need to find our integrating factor and we'll see where we go from there. Looking at this, now you can either spot it, all right, you can probably spot it. Let's just go for that. I'm going to multiply everything by x, because then I get x dy dx plus y equals 5x over x squared plus 2. 4x squared plus 3. Now the real kicker here is, now this is a product rule, which is nice, but we are going to have to integrate this, which means partial fractions. So let's take some space down here and get our partial fractions. So 5x over all of that, x squared plus 2, 4x squared plus 3. Is equal to ax plus b over x squared plus 2, cx plus d over 4x squared plus 3. See all that partial fraction stuff you do over at Neil Does Maths. It's all useful. We're going to use it loads. Multiply it all up. Times x squared plus 2 plus cx plus d times 4x squared plus 3. We can plug some numbers in, but it doesn't look like it's going to be particularly nice. So let's have a look at the x cubes, shall we? I should have no x cubes, and that should be a from that one plus 4c. Okay, not too bad. Let's look at the x squared. I should have none. And how am I going to get x squared? So I'll get b from that one, and I'll get 4d from that one. Yeah. Then we're going to look at the x's, and I should get 5 overall, and that should be 2a from that one, and it should be 3c from this one. Ooh, okay, so I can probably find a and c already. And then just the constants, I should get none, and that's going to be 2b plus 3d. Right. Now, these two tell me that b and d are equal to 0. Now let's solve these two. Let's solve these two. So multiply that one by 2. 0 is 2a plus 8c. 5 is 2a plus 3c. If I subtract, I'll get minus 5 is 5c. So I'll get c is minus 1. Minus 8. That gives me a is 4. Cool. All right. So where does that leave me? It leaves me with the left-hand side of this is the derivative of xy. That is equal to, so 4x over x squared plus 2. Does that feel right? Yeah, we did it. C is minus 1, A is 4. Yeah, that goes into there. All right, all right, all right. Minus 1 over 4x squared plus 3. I'm feeling the need for a cheeky little bit of a crib here. Yep, no, I seem to agree with myself, so that's nice. So let's integrate both sides of this. I end up with xy. Oh, that should be a minus x, shouldn't it? Right, because c was the, yeah. Have I got these the wrong way around? I do. I've got them the wrong way around. I know what's going on here. Right. You'll notice here, the more astute of you must have been yelling at your screens for the last few minutes. You'll notice when I multiplied this up, that should be these are the wrong way around. So what we're going to do is I'm going to be a little bit sneaky here. And that will become the x squared plus 2. And that makes life a lot better. There we go. There we go. Ugh, attention to detail. Right, now, this is very nearly the derivative of this. We're out by a factor of 2, so this is 1/2 ln of 4x squared plus 3. And same here, we're out by a factor of 1/2. That was the clue that I'd mucked up, because I knew they had the same factor in front of them. Plus some constant. Now, this constant we can do a whole lot with, but I'm going to call it 1/2 ln A. The reason being is I'm going to want to make one big ln with all of this. So it makes my life a lot easier if I end up doing it this way. There we go. Right, when x is 1, y is all of that. So let's plug that in. I end up with ln 7/6. Well, 1/2 ln 7/6 is 1/2 ln of a times 7/3. Well, that tells me that a is equal to 1/2. Therefore, divide by the x, y is 1/2x ln of 4x squared plus 3 over 2 times x squared plus 2. Yeah, minor little hiccup there. A little bit of a sneaky look at my notes. It happens. Awesome. You might want to go back and double check for yourself that you are happy that the integrating factor was in fact x. Very simple to look at there. And then more partial fractions on the right hand side. It's a nice illustration of where all this partial fractiony stuff comes in and helps us solve bigger problems as well. Anyway, if after this you still trust me, I hope you do. We are running cram sessions heading into your exams, which means that you can sign up using the link in the description to this video, and the night before your further maths exams, we will hang out and do 5 hours of live stream where we go through exam style questions, we go through any queries you might have, any last minute doubts, and we will build you up so you go into that exam the next day feeling on fire, like you're going to absolutely crush it. So, if that sounds interesting at all, go check out the link in the description, and hopefully I'll see you then. In the meantime, I'll see you for the next one of these. I'm Nick, this was Maths. See you next time.